Welcome to this video introduction to studying physics at Nishkam High School. My name is Mr. Cresswell, and I'd like to start by saying congratulations for your interest in this topic. Despite its incredible importance to every aspect of our technological world, those with an interest in physics are a rare and special breed. The curiosity to learn about the universe is a wonderful gift, and to study nature at its most fundamental level is perhaps the best celebration of its complexity and its awe-inspiring scale. The Nishkam Physics Department is committed to sharing our knowledge, our skills and our passion for the subject with every student who walks through our classroom doors. We are lucky to have small class sizes so that we can offer one-to-one time with our students and ensure that all are keeping up with the course. We believe in both supporting our students academically as well as taking a virtues-led approach to their education. I can say that Nishkam High School is a fantastic place to work, and I believe it's a wonderful place to be a student as well.
Hello everybody, I'm Mr. Douthwaite. I studied physics with applied environmental science at Keele University. The area I particularly enjoy teaching in A-level physics is conservation of energy calculations. It's a theme that runs throughout the A-level, varying from kind of like simple cases that we do at the beginning of year 12, where we've got gravitational potential energy becoming kinetic energy or vice versa. And then there's kind of like complex examples of that in year 13 in nuclear physics, where we look at the closest approach of an alpha particle to a nucleus, and that's in the context of the Rutherford experiment. If you choose to study A-level physics, you'll develop your virtues of diligence and creativity. This is particularly in reference to the problem solving that is the nature of physics, and even if you go on to a kind of a degree or career that's got nothing to do with physics, this problem solving is something that's really of great benefit to develop whatever you go into.
Our lessons will take place in laboratories with access to a wide range of apparatus for a variety of experiments and opportunity to explore physical concepts. We know that it's not enough just to read about physical concepts, but it's important to explore concepts practically so that students can get hands-on experience to both develop understanding and consolidate their learning. So let's look at what you can expect in your physics lessons. Experimentation to determine the mathematical relationships between physical quantities. We will complete a minimum of 12 required practical experiments to develop the investigative skills required for a university science degree course. We will also do a number of other experiments in order to help students understand the key concepts that we'll be covering throughout the course. The required practicals are designed to increase your confidence and independence as you move through the course in 4 separate phases. In the first phase, the teacher will show you and you will copy experimental setups. In the second phase, you'll be able to do it yourself, but you may need to ask the teacher every now and again if things go wrong. In the third phase, you can get most of the way through without any support or guidance, but may need to check on a few details. And finally, by the end of the course, you should have no problem both creating the experiment and performing it. You'll be assessed on being able to follow written procedures, take investigative approaches, work in a safe manner, make careful and precise observations, and research and reference and make reports on what you've learned. Exploration and understanding of physical concepts. We will be taking a qualitative look at the universe, from the scale of subatomic particles through to the scale of planetary bodies. So this could be anything from looking at how baryons and leptons interact with one another, through to looking at how Newton's laws of motions apply to moons orbiting planets. Mathematical descriptions of the relationships between physical quantities. We will be learning and applying mathematical equations to make predictions and find missing variables. Mathematics is the core of physics. We often describe mathematics as the language of the universe, so we'll be using a large portion of our course in order to look at these mathematical relationships. What you will study in physics: particles and radiation, where we'll take a look at subatomic particles and the quantum phenomena that affect those subatomic particles. Waves and optics, where we'll take a look at mechanical waves, electromagnetic waves, and optics including diffraction, lenses, and fiber optics. Mechanics and materials, which is perhaps the largest and most diverse topic within our course. Static forces, forces and motion, Newton's laws, momentum, energy conservation, material properties, motion in a circle, and simple harmonic motion. Electricity, where we'll take a look at electrical current and analyze DC circuits. Thermal physics, where we'll take a look at specific heat capacity and specific latent heat, as well as the experimental gas laws and kinetic theory. Fields, in which we'll take a look at gravitational fields, electrostatic fields, magnetic fields, and electromagnetic induction. Nuclear physics, where we'll look at radioactivity and nuclear energy. And finally, turning points in physics. We'll take a look at the discovery of the electron, wave-particle duality, and special relativity. These are the key moments that history changed as a result of new physics discoveries. How will you be assessed in physics? Throughout your course, you'll be doing these 12 required practicals. As you do so, we will be assessing your competence. We do not expect you to be perfect at first, but by the end of the course, we expect you to be able to complete a required practical independently. You will then be given a pass or fail grade on the practical side of the course. You will then have 3 terminal examination papers. Paper 1 includes the topics of particles and radiation, waves and optics, mechanics and materials, and electricity. This will be a 2-hour exam with 85 marks. Paper 2 will cover the topics of thermal physics, fields, and nuclear physics. It will also expect you to remember elements from paper 1 as well. It again will be a 2-hour examination paper with 85 marks. And finally, in paper 3, it will consist of 2 sections. Section A, which assesses your practical skills and data analysis, and section B, in which you will complete the options topic. We can offer a wide variety of extracurricular opportunities in physics. Currently, a number of universities are running online physics events, which our students will be invited to participate in. These cover a wide range of topics, with the favourite being particle physics, as well as careers events run by the National Space Centre, led by experts in their respective fields. Now, where can physics take you? This is an incredibly broad question because it has an incredibly broad answer. Physics can take you literally anywhere. In fact, when I finished my physics degree, I was looking for career guidance. I wasn't entirely sure what I wanted to do. When I asked the career guidance expert, they said, well, you can pretty much do anything you want. I was told I could go and take a law internship. I could go and work in finance. I could become a teacher. I could go and study to become a doctor. Physics is a gateway to almost any career imaginable. If you get a first or a 2-1 at university, every career opportunity will be available to you. Now, what we expect from you. Conscientiousness. both a commitment to studies and an attention to detail. A conscientious student is always punctual, arrives with all equipment necessary, and meets all the deadlines. You will also need to be an expert mathematician. You'll need the ability to understand a mathematical question, choosing the correct information and relevant mathematical formula to solve a problem. An expert mathematician can rearrange equations with ease and solve complex equations using a systematic and logical approach. And finally, spatial awareness. The ability to visualize physical situations and create appropriate diagrams is invaluable within this subject. A student with good spatial awareness can derive useful information from diagrams and create their own in order to ascertain more important information about a given scenario. Our student perceptions. Students find the course both challenging and rewarding. They recognize the difficulty of the course, but they approach it with commitment, diligence, and optimism that allows them to succeed. Below are some quotes from students. Qualification details. Now, in order to make it onto our physics course, you must have a minimum of a 6 in physics or a pair of 6s in combined science, a 6 in mathematics, a 6 in English, and 5 GCSE grades 6 to 9. All of the Nishkam Sixth Form Open Evening resources can be found on the school's website within the Sixth Form section. Applications are also now open and are available to complete electronically through the Apply section of our Sixth Form page. We look forward to welcoming many of you to our classrooms in September 2021.